Today we're going to do more work on math with polynomials. We're going to be working on dividing polynomials. That's section 12.5 in your book. Dividing polynomials might look a little bit like this. Now at first we're going to start out with where we're just dividing by a monomial. So I have a binomial here and I'm dividing by a monomial here. Well, that might be similar to if I had x plus 4 divided by 2. Notice that both of these have a common denominator, and that common denominator is 2. So I could rewrite this as x over 2 plus 4 over 2. So I could say that's x over 2 plus 2. I'm going to do the same thing here because I do have a monomial, just like this is a monomial. So I'm going to take the top part and I'm going to rewrite it using the bottom. So at first I might do this so that I can see it done up and down. And then I'm going to turn around and I'm going to put the monomial on both of those terms. So I have 3r squared over 3r minus 15r over 3r. So then I go back to what I've learned how to do already. I reduce up and down. So 3 over 3 is 1. Understand when they mark out, they're not equal to 0, they're equal to 1. That's going to give me an r on the top. This is going to give me a 5 over 1. And the r's are going to equal 1. So on the top, actually I have nothing left on the bottom except for the 1. And so therefore I don't have to put it. So I have r minus 5 over 1 or r minus 5. And that's the answer to that division problem. All right, let's do another one. This time I have a trinomial. N squared plus 10n plus 12 divided by 5n. So I can write it up and down, n squared plus 10n plus 12 over 5n. This denominator goes with each one of those terms. So I have n squared over 5n plus 10n over 5n plus 12 over 5n. All right, the first term, my n's can reduce down. So on this term I have an n plus 5. The 10 and the 5 become a 2 and a 1, and the n over n is equal to 1. So that's plus 2, and then I can do nothing to that last term. So that right there is my final answer for that division problem. All right, now I want you to try a couple. So you're going to pause the video and come back to it and see if you got your answer correct. Okay, that's the first one, and this is the second one. So do the problem and then come back to the video. All right, I'm going to write this separated out. So I have 4x squared over 2x minus 18x over 2x. 4 over 2 becomes 2 over 1. X squared over x becomes just x. So the first term reduces down to 2x. Minus this term reduces down to 9 over 1. And the x over x is equal to 1. So I get 2x minus 9. That should be your answer for the first one. Then on this one I have 2y squared over 3y minus 3y over 3y minus 9 over 3y. Can't do anything with the 2 and the 3, but I can take the y squared over y, and that's just y on the top. This one, it doesn't reduce down to 0. Because they match on the top and the bottom, it reduces to 1. Because 3 divided by 3 is 1, and y divided by y is 1. This reduces down to 3 over 1. So I have 2y over 3 minus 1 minus 3 over y. So this right here is your answer to that question. All right, now let's do more than a monomial on the bottom. Let's work on dividing by maybe a binomial on the bottom. Here's an example of that. Say I have s squared plus 6s minus 7 divided by s plus 7. Okay, if I write it up and down, I've got s squared plus 6s minus 7 over s plus 7. Now remember, when I have a binomial or polynomial, I have to cancel out the whole thing. I can't just cancel out the s and cancel out the 7. So the very first thing I'm going to do here is I'm going to factor. So I have s plus 7 and s minus 1. That's what this factors into. On the bottom I have s plus 7. So you can see that the s plus 7 over the s plus 7 is equal to 1. So my final answer is s minus 1. All right, I'm going to put one up here for you to try. Remember, you're going to factor it. You factor anything in the problem that can be factored first. So here's the one for you to try. 2r squared plus 5r minus 3 divided by r plus 3. So pause the video, do it, and then come back. All right, so I have 2r squared plus 5r minus 3 over r plus 3. I'm going to factor the top, and it factors into 2r and r, and let's say 3 and 1, because this is going to give me a positive 6, and as long as that's a negative r, negative 1r, that'll work. So that's what that factors into. The bottom is r plus 3, so those two go away, or they're equal to 1, and I get a 2r minus 1 as my answer. All right, one other concept that we're going to work on today is actually long division with these things. When you think of long division, you probably have a negative feeling of when you first learn long division. Long division with polynomials is much easier, but it is along the same lines. Your technique is very similar to normal long division. Let's say that I have x squared plus 3x minus 24 divided by x minus 24. Now you could do it the way that we just did these problems, okay? In fact, let's do that first and then I'll show you the long division on it. If I were to factor the top, I would have x plus 6, no, let's see, 8. 8 and 3, that's not going to get, actually I don't think I can factor the top. So 6 and 4, that's not, okay, so I have to do it by long division. So this is what's going to be my divisor. And this is going to be my dividend. Okay, so this goes outside the divider thing. This goes underneath. Okay, and what I have to do is I know that I've got a binomial here. So it's going to go into the first two terms. The only thing I have to do is I have to look at the first term and say, what times x equals x squared? Well, x, because x times x is equal to x squared. So I only have to worry about the first one, but I'm actually multiplying it by both of them. So x times x is x squared. X times negative 4 is negative 4x. Then, like normal long division, I'm going to subtract. Well, this is where you can run into problems because this is 3x minus a negative 4x, which actually gives me 7x. If you need to, over to the side, write it out so you don't mess up the positives and negatives. Okay, so I've got 7x here. Obviously, x squared minus x squared is equal to 0. Now, that if I don't get 0 in that first spot, then I've picked the wrong thing up there. All right, now I'm going to bring down that minus 24. X goes into 7x. What would I have to multiply by 7, or by x to get 7x? Well, I would need a 7. So 7 and a positive 7, that's why it's a plus there. 7 times x is 7x. Remember, that has to match up. 7 times negative 4 is negative 28. Then I'm going to subtract. Remember, I have this minus this. So it's negative 24 minus a negative 28, which is the same thing as saying negative 24 plus 28. So I get a positive 4 right there. Well, the way I do division, if you remember right, you take your remainder and place it over the divisor. So I can turn around and go plus, because notice there's plus in between each one, 4 over x minus 4. That's my answer when I divide that. If I turned around and multiplied this times this, it would give me this polynomial right here. All right, let's try another one. You can see that it's a little different, but it is easier than what we think of as long division. So long division with polynomials is easier than long division with just numbers. All right, the x minus 2 is going to go on the outside. This part's going to go underneath it. First thing I do is I go x times what gives me x squared? Well, I would need to multiply it by another x. Because this is a binomial, I'm taking it in to the first two terms. So it goes over top of the 7x. So then I multiply. X times x is x squared. X times negative 2 is negative 2x, or I could write minus 2x. All right? Then I'm subtracting. 7x minus a negative 2 is the same thing as 7x plus negative 2, so that's 9x. I'm going to bring down the 15, and then I'm going to divide again. X times what gives me 9x? Well, x times 9. So, and remember, plus in between each one of these, 9x minus 18. So I'm subtracting to get my remainder. I'm going to go negative 15 minus a negative 18, which is going to give me a positive 3. So then I'm going to take the 3 and I'm going to place it over the divisor. So this right here is your answer for that division problem. All right, now I want you to try one. See how you can do on it. Well, actually, we better do this one together because it's got a different little step to it. Notice that I go from x cubed to just x. If that's the case, I have to put a just a placeholder in there. So I have an x minus 5 on the outside. Then I have x cubed. I must put the placeholder, so it's 0x squared minus 34x plus 45. So if you are skipping exponents, you must put a placeholder in there so that it goes 3, 2, 1, 0 as far as your exponents go. So then I proceed to divide just like normal. X times what gives me x cubed? X squared, because x squared times x is x cubed. Remember, it must match up. Minus 5x squared. So I have a 0x minus a negative 5x, which gives me a positive 5x squared. I bring down the next term. X times what gives me 5x squared? I would need a 5 and another x, which gives me 5x squared minus 25x. Negative 34x minus a negative 25x gives me the same thing as negative 34x plus 25x, which is going to give me a negative 9x. I bring down the next part. This I would need to multiply by a -9 to get that, so plus a -9. So I have a -9x plus 45, and you can see that those totally match up, so when I subtract I get a 0. This time I have no remainder, so my answer to that is x squared plus 5x plus -9. All right, I'm going to give you some homework on this to try. It is page 669, 12 through 30 even.